Excellent. Thank you, Drew. And my wife would disagree with you that I know what I'm talking about, but that's a separate talk, separate discussion. Hello, everyone. Is my mic okay? You guys good in the back? Yes, no? Perfect. Awesome. Hello, everyone. My name is Colt McANLIS. I'm a developer advocate at Google focusing on Chrome gaming, which effectively means that while everyone else is working on search engines, I get to go play video games all day, because that's all you do when you make games, right? Just play games all day. Again, at least that's what my wife thinks. Anyhow, what we're talking about today I think is very topical. If you've been in the tracks most of the day today, people have been talking about technologies that allow you to write your code once and run it in multiple locations. Predominantly because of the fact that as developers, we want to reach the most users possible. Like, this is the big goal, right? Like, we want more users, more ROI, more paying customers, more freemium-enabled content, all of these sorts of things. But what we've been neglecting is the fact that having the larger discussion that C++ has been around for a long time, and in reality, you can actually get C++ on the dominant set of all of these platforms that are out there. You can run C++ on mobile. You can run C++ on console and on PC. And really the only problem that we've been missing right now is really tapping into that web sector. And this is where the technology of native client comes in. So when we talk about C++ running on the web, there's two primary factors that we need to address, right? Because this is the scary thing. Number one is we want to talk about performance. This is the critical solution here. And then number two is we actually want to talk about security. Because as I'm sure most of you remember, some of the initiatives to run arbitrary C++ code on the web in the past has resulted in a lot of malware, a lot of potential attacks and everything else. And in general, x86 code is not really a nice language for security processes, and we have to kind of address that directly. So before we dive in too deep, I actually want to take a look at what a web browser actually does. So how many people in here have actually written a web browser? I just saw the camera lady's hand move up. Did you write a web browser? No, okay, she's just adjusting. That would have been pretty cool if you wrote a web browser too. But yeah. Anyhow, so a lot of people, when they think about web browsers, to them, they don't either make the connection that the web browser is actually just a standard piece of software, like any other game or application. They forget sometimes that it's not a magical cat video delivering device. Like, it's actually C++ code. It's actually running content. And if you look at the way Chrome is architected, for instance, Chrome takes your JavaScript code, which powers the backbone of the internet, and it actually executes it on top of a virtual machine. This is a C++ virtual machine called V8. So it takes your JavaScript code, it interprets it, it executes it, and ensures that it's safe, that it's translating between the JavaScript APIs, the underlying APIs that the system's providing, and this allows it to actually run on top of the platform. So in this case, we're just going to say it's running on x86 code. So with this sort of mental model, you have to, again, realize that a given web browser and the code involved with it that powers sort of the magic that is the internet that keeps us all so happy and whatnot is actually no different than a scripting language that's running in any game, right? You've got a semi-interpreted language, you're running on top of a virtual machine, and you're trying to get performance out of that. And this is where the critical discussion comes in. What about performance? So we've seen some great talks today talking about sort of these interpreted languages, especially about HTML5 in general, but we have to look at where the performance really is. So this is a really good graph, because as coming from a graphics programmer background, I really like to benchmark things in relation to what the GPU can do and what types of operations we have involved there. So this is a really simple graph here. What you're looking at is actually a simple demonstration of skinning vertices. So skinning vertices, effectively, you're taking bones that define a 3D model, and you're updating the position of those vertices in the model based upon the translation of the bone. So you're animating a skeleton and then updating positions based upon it. So on the GPU, in a natively bald guy stupid implementation, we can easily skin about 200 million vertices a second. Like, this is the stupid way to do it. In reality, with the latest devices, the Tegra GPUs, some of the larger Quattros, you can actually probably get it closer to 800 million vertices skinned a second, but for my stupid implementation, it was around 200. With SIMD support, this is a single instruction multiple data support, SSE4 on C++, we get around 100 million vertices a second, so doing it all in software mode. If we translate that algorithm to the best known implementation inside of JavaScript, we get about 8.4 million vertices a second. That's not just a magnitude off, that's a very considerable difference. That's the difference between being able to actually run an RTS and run a first-person shooter with only one other guy shooting at you, right? Like, that's a considerable difference in the performance gating the type of content that's available there. So when you take a look at JavaScript as a platform, you have to sort of rank it in what it can do because of the fact that it's running on this interpreted virtual machine, right? Virtual machines, effectively, by definition, they take all of your operations, all of your executing code, they run it through their system, they ensure that you're not going out of bounds arrays, they're trying to make sure that your garbage collection is working properly. All of this functionality is provided, but effectively you're paying for it in terms of performance on the underlying system. So how people are starting to address this, and again, some of the talks today and yesterday at Casual Connect have done a great job of discussing this, is actually, can we get C++ running in the web through other means, right? One of the probably the dominant forms of doing this right now is actually a process of conversion, where they'll actually take your C++ code, run it through a language translator, and actually generate the platform-specific language code for the application you're looking for. Mscripton is probably one of the most popular versions of this, that'll actually take your C++ and generate direct JavaScript. It's got some really cool stuff involved with it. It'll actually take your C++, compile it to an LLVM bytecode, and then actually translate that LLVM code to JavaScript itself. And then it does some really amazing things with ensuring that garbage collection works with sort of a binary array setup and everything else. You can see that this actually has some really great results. This is a video game called Cube 2 Sauerbraten. And what this is a full C++ game actually ported and running inside of JavaScript using a similar process to this. This one's actually using the Mandrill framework, which goes through a very, very similar conversion, right? Take your source C++ code, convert it to some interchangeable middle binary format, and then the output of that can actually go to JavaScript. Now, this is actually running at 30 frames a second. Now, for those of you who know the Cube 2 engine, it's effectively about a Quake 3 era style engine. I mean, you still have software emulated shaders. You have a fixed function pipeline that does most of the heavy lifting for you. But in general, you get some really good effects. So with this, you can actually kind of run C++ on the web, but you're losing a couple things. For instance, where the hell do you set your breakpoint? Right? I mean, if you're actually taking your C++ code, converting it to this middle range, and then exporting it out in some other sort of language, you lose any concept of debugging or actually tracking down where the problem was. Let's say this thing crashes. Is it on your side of the fence? Is it on their side of the fence? Where's the crash actually occurring? You lose a lot of data with this setup. So the good news is, though, that the C++ performance can at least get there, right? I mean, being able to run an FPS at 30 frames a second inside the web browser is actually really cool using some of these translation frameworks. But the next problem we have to talk about is security, right? So this is what C++ on the web looks like today, right? The user's sitting there, they want to actually run the application that you're providing, and they get some really cool dialogue that's like, this is not a virus.exe, please click me, right? This is the plugin problem that we're seeing today. And yes, I actually had to fake a certificate to make this. This isn't Photoshop. This is actually me writing a binary, actually faking the certificate to get Chrome to show up this data, because that's what you do with your free time when you work at Google, I suppose. Anyhow. This is where users are seeing mostly C++ code occur today. What will happen is the executable will come down, usually install a plugin or some other setup, and then after that, the user can execute the arbitrary C++ code that's occurring. Of course, this is what happens with that, right? This is where we're at in this sort of setup, is you end up with your web browsing experience being really crummy for a couple reasons. Number one, that code that's being executed, chances are the users don't really know what's going on, and really there's no barriers involved to what that software can really do to them. So for instance, you can go install Bubble Poker 7, and then all of a sudden your tabs look like this, and all of your credit card information now lives in Shanghai. Shanghai's a beautiful city, nothing against Shanghai, I don't like my credit card data there. This sort of makes users very hesitant to push that install button, right? I mean, you can understand why. And so we kind of took a step back and said, how bad is this problem really? And so I started looking at some plugin-based frameworks that are on the web today that are running on very popular gaming networks and actually have real data. And I started looking at what their visitor statistics were like. And so this is one day of behavior. So if you consider the pie graph, 100% of their users that came in that one day, 54% of them who visited the site did not have the plugin and left immediately. That's a pretty scary statistic, right? In the age of gaming that we're in now, where the focus is in how many users can you get, how many daily actives, how many uniques, you're losing 54% of them that will never get through the door simply because they're prompted to install a plugin. That's an alarming characteristic. 24% of the people actually installed the thing, and then 21% was actually returning traffic who already had the thing installed. So I didn't have corollary information that showed this sort of long tail over time about who installed it and how many times they came back. But really, the blue thing should scare you, right? How many of us, or better yet, how many applications out there in the area are about user retention, user metrics, getting people in the door and keeping them in your app. And then you see statistics like this that shows that that's all fine and dandy, but you got to get them in the door. Losing 54% because of a plugin dialog is simply unacceptable. And this is where native client comes in. When you take a look at performance and you take a look at security, this is why we built native client. Native client is a tool suite that allows you to run x86 code, or C and C++ code, directly in a web page as safely as JavaScript with no plugin required. That's the cool part, right? You can actually execute your x86 code right in the page. The user doesn't get a dialog, they don't get a pop-up, they can just hit the button and go. You get that 54% back, and that's really important. And you can be sure that this is actually running as fast as possible, because the way that native client works is it's not running your C++ code through a VM. It's not interpreting it to some other bytecode language. It's actually executing the x86 code that's produced from the compiler directly. Right? So those of you who've done lower level system programming, you can think of this almost like a set jump, right? A load address reference. So effectively, Chrome will give up execution code or execution control to your x86 code, allow it to run on the native device, and then ask for time slices back when it's time to do. So that's pretty much as fast as you can get, right? There's no meat between your code running and the layer that's actually below it. And this is probably one of the first public timings that we actually produced as the native client team. This is actually a demo called Flocking Geese, and you can actually go find it on the Chrome Web Store and on the native client development website. That'll actually show you a side-by-side comparison of a flocking algorithm, like a bird aviary-based flocking algorithm, implemented in JavaScript and implemented in native client. And you can, you got some controls on the side that allow you to tab back and forth and see what the performance is. But at the best, testing about 1,000 objects in the scene flocking around, native client has a 13x perf increase over JavaScript. And that's a very complex algorithm, right? So, of course, your timings may vary depending on your system and what your x86 execution would look like. And again, this is the brain-dead version, right? Like, this isn't going through SIMD support or typed arrays or anything else. This is, again, a bunch of bald guys sitting around writing some code, because that's all we do. We don't have hair. We can't look good in front of people. So here's the best part, right? Not only is that running that fast, but it's the exact same code. In fact, performance is so well that comparisons of the exact same code base running in the browser versus other platforms is damn near identical. What you're looking at here is actually a picture from a convention last year, a game called Star Legends, and this is actually running their game on an Android device right next to their browser version running a native client. Now, for those of you who don't know, Star Legends is an MMO. It's a free-to-play MMO. And what they have set up here is you can actually play your Chrome version in your web browser alongside your Android version. You can play right against the players, no problem. It's the same code base. Floating point is all the same. Endianness, it's all the same. You're good to go. And this is really the vision here, right? Using your C++ code for your existing applications that you've already put on these platforms, running it in the web browser so you get access to more users. So this is all fine and dandy, right? Like, that's the whole product pitch and understanding where we're going. So let's talk about how it actually works. It all starts with your existing C++ code base. You take this C++ code and you compile it with a GCC-style compiler that we provide as part of the native client SDK. What happens is this produces a set of files that are used to actually run your native client application. Probably the most important one here is the NIXE, or Native Client Exe. This is a modified platform-agnostic set of CPU code. It's effectively x86 code that's been wrapped in an ELF binary format. So Linux developers, ELF binary format. Yep, one dude. You get a t-shirt. I like your style and your head nod. That's cool. He raised his hands. He's like, yeah, Linux. I got that. So, anyhow, these NIXEs are effectively placed on the web server once you want your application to actually run. And then to access them, you put a simple embed tag in your HTML file that actually points to the manifest file that defines what NIXEs you have available and what opportunities you have. And then once your user loads this page, they get this. This is a product called Airmech. It's a real-time 3D real-time strategy game. Real-time strategy? I don't know. Anyhow, it's a real-time strategy game running in native client in the Chrome web browser right now. You can actually go get this game. You can play it right now. It's from Carbon Games. It's called Airmech. And this is the full thing, right? They're doing hardware skinning. They're doing particles. They're doing 3D physics. They're doing pathfinding. They're doing everything you would expect out of a console-style experience running right in the web browser using their existing code base. They didn't have to translate their code base over to some other intermediate format. It's the same setup they have there. So once you understand the big picture, it's worth taking a step back and discussing a little bit about what the porting process to native client looks like. So when I say you use your same code, there's a couple caveats on that, right? So Chrome and the web is about platform agnostic development, right? We've seen that with JavaScript and other languages. And native client really isn't different than that. We want to make sure that as you write your code, it'll run on the most platforms possible. But because of this, there's some things that aren't supported on every platform. So for instance, if you were porting from Windows and Linux, you'd kind of have a specific step of things that you'd have to do. Number one is Linux doesn't have DirectX, right? So if you're porting from Windows to Linux, you'd have to convert your DirectX code over to OpenGL. So porting to native clients is somewhat similar. In addition, there's a whole suite of APIs that provide similar functionality on the Linux platform that Windows has chosen to overload in terms of API set. So for instance, the begin thread command will actually launch a thread and do everything fun with that. Linux, of course, provides pthread create, which launches a thread in the same context. And then there's some suites of APIs that Windows provides that Linux just doesn't have at a functionality level. So for instance, Windows has message box. Just pop up a message box, tell the user that you're out of memory and move on. Of course, Linux doesn't have this, so you have to just use printf and move forward. Well, with this sort of concept in mind about porting platforms is actually a roadmap of mapping platform-specific APIs over to something that's a little bit more platform agnostic, you start to get a picture of what it's like to actually port to native client. But with native client, because we have to sort of wrap up some things, you're not actually just porting to a POSIX standard, you're porting to an API that we call Pepper. Now, what is Pepper, right? So native client, by the way, the abbreviation is NaCl, sodium chloride, right? NaCl, like table salt, and so we have the API called Pepper. That's clever. There's people at Google, they're clever people. Anyhow, the Pepper plugin API, or PP API, is actually an API that Chrome, the web browser, exposes to external plugins that allow them to extend the functionality of the browser, right? This API allows these plugins to actually get access to lower-level resources like file I/O, rendering, audio, and even the ability for that plugin to communicate directly to the JavaScript that's in the page. So this actually allows you to write a plugin and actually have it manipulate the DOM, communicate with things in the website, even execute arbitrary JavaScript inside of the web page itself. Now, native client, in order to allow access to these lower-level resources, allows you to target the Pepper APIs in your executable code. So when you're writing your C++ code, instead of calling fread, right, which just allows you to arbitrarily open a file on the user's disk, by the way, really bad for security, Pepper provides its own version of file reading so that you can be sure that you're executing this in a platform-agnostic manner that's safe for the user's underlying system, right? Because again, the browser side, we actually have to care about security a lot more than most people would think to make sure that your application is running in a trusted environment that the user can feel good about. So, but anyhow, what happens is your compiled Nixie will actually target the Pepper APIs, and native client will effectively allow these APIs to trampoline jump into what the Pepper function calls are actually looking like. So again, high-level description, you compile your C++ code, it generates everything. Your C++ code needs to be modified to port to the Pepper APIs. And with the help of all that, we actually launched native client about a year ago. So December 2011 was our official launch, although native client had been running in Chrome since about Chrome 13. But one of the big things that we actually just announced at Google I/O a few weeks ago is an add-in support for Visual Studio. So now, if you're Visual Studio developers, you can actually develop your porting efforts for native client and Pepper alongside your existing development methodologies. And this will be provided and available with the Pepper 22 SDK. Check the website for details. And talking a little bit more about what we've been doing since our launch event, native client is actually doing really awesome. Since the launch in December, we've actually had over 24 games ship on native client, as well as a handful of very popular games middleware. For instance, Havoc actually has a native client build, which means if you're a game developer running a very popular 3D game on console or desktop or mobile and you're using Havoc, it's already supported with native client, and you can actually move your code over with minimal effort. Unity is actually worth pointing out that the standard Unity web methodology is actually to install a plugin. So the user is prompted to install a plugin. But Unity also supports a native client route, which means you can actually outport from Unity to native client. And if the user is running Chrome, they're not prompted for a plugin. It loads, it runs, no barrier to entry on that regard. Probably one of the coolest things about this is that a lot of small companies, like the ones here at Casual Connect, view native client as a great way to reach people, but larger companies are realizing the mass appeal here too. This is actually a quote from some of the bigwigs over at Square Enix. With the power of native client, Square Enix is pushing the boundaries of browser gaming market to include high-quality games in addition to our popular portfolio of casual games. These guys get it, right? Square Enix is a very large company with a very long history of C++ games. They've got billions of dollars invested in training their people, creating large code bases that run across platform, stomping out all the bugs with STL containers, or just getting rid of them, because you should think about that too. Anyhow, they've got billions of dollars invested in these legacy code bases. They don't want to have to rewrite everything just to be able to move it to the web to reach all of the users there, right? And because of that, they've already launched one game called Mini Ninjas, which was an Xbox 360 title. At Google I/O a couple weeks ago, they announced that Lara Croft Guardian of Light will actually be coming to native client. This is the second title in a larger commitment that Square Enix is making to bring over content to the web. And this is actually a screenshot from the game running inside of native client. This is a full Xbox 360 rendering engine running inside the web browser. So when a lot of technologies have talked about today about running console experiences in the web, this delivers it at the code level, which is really an amazing thing. So I know this is Casual Connect. I know I only have a little bit of time with you guys, and plus most of you eating sandwiches. So that's really all I got to talk about today. You guys want to know more at the technical level, I highly encourage you to visit gonacl.com. That's our developer website. It's got all of our source code, SDKs. It's got postmortem examples, documentation. It'll even show you an application gallery of native client apps that are in the wild now that you can go play with. And you know what? See it for yourself. Take a test drive of the technology and let us know. My name is Colt McANLIS. This is how you get a hold of me on every medium. I think we're done. Let's open the floor for questions.
If you've got questions, we've got time. So let's take them.
That dude's head shot up before the word question was out of enough.
No, I'm just wondering, what is the state of other browsers? How receptive are they to native client? And what can we expect in the next 3 years out of native client as a platform, like support and just user reach for internet users?
See, this is always the trick with people asking questions. They always ask two. It's always like, I've got question A and I've got question B. That's cheating. So your first question is, how receptive have other browser vendors been to native client? So here's what we do at Google. We're very on board with open source. Native client's completely open source. Chrome is completely open source. And I'd like to point out, and I'm sure most of you know this, that since Chrome has been open source, we've been seeing amazing performance and capability upgrades with other browsers. For instance, how many other browsers have adopted auto-update philosophies now, right? So the fact is these other browser vendors are watching Chrome closely and emulating a lot of what we're doing. Our plan is to show the fact that native client should be something they should emulate as well. It's open source. You can go out. You can use it right now. We've already been seeing massive adoption from the games industry showing that you can do this high-performance programming right in the web. So we're very hopeful about it. That's really all I can say on that. So then your second question was, because you asked two, cheater. Your second question was, what can we expect with native client over the next couple of months? Well, the first thing you should look about on the horizon is a new technology called portable native client. This is sort of native client's big brother that will allow execution for more devices in the future. As I pointed out today, native client really executes well on x86 platforms. Portable native client will open the door for ARM devices and other potential platforms in the future. With that, we're listening very intently to the developer community. We're trying to keep adding more tools, more support for platforms, better integration with IDEs, fixing a lot of the problems that we have, finding any performance bottlenecks that exist there. Basically, we're trying to make the transition from your C++ code running on any other platform to native client as minimal as possible. So that's the things we're actively working on. Thank you. Microphone.
You mentioned POSIX earlier, and then Pepper.
Yes.
But Pepper is not something that you guys are trying to standardize through any of the standard bodies, like ISO or ECMA or?
Not necessarily. So Pepper is a plugin API that Chrome provides. So we took a look at the NP API. I'm sure most of you are familiar with that as an API standard. And we actually found a lot of programming and security and performance holes with that. We just really, as the Chrome team, really didn't feel that it answered all the problems for a modern web with security. So that's why we developed Pepper as an API standard. Now, we're not going out of our way to try to standardize that. What we prefer is to have proper dialogues with people about what it looks like to expose these sort of plugin-based APIs in a safe and secure manner that doesn't, force deadlocks in the systems and allow you to communicate things in an asynchronous pattern. That's really what we wanted to go to here. But we don't really have a lot of initiatives in play right now to try to standardize that through the W3C, which is more like it's really weird, right? You've got a web consortium which sort of talks about standards for the technology running on the web, but there's really not a standardized body about how you should actually expose plugins and functionality for the web browsers you generate. right? So it's kind of, right now how it works is the W3C will define some statistic, and then all the web browsers rush to implement it, and then their implementations can be off by some degree or operate differently under different circumstances and whatnot. So it's kind of, it's like any other platform.
I've got one question myself. Which versions of Visual Studio do you support?
Yes, so the plugin that will be shipping with Pepper 22 will be generated for Visual Studio 2010. We've taken a look at Visual Studio 2008 about what market share it means, and then how difficult it is to support and what you get from that. And we really felt that Visual Studio 2010 was sort of the barrier to entry for us to get the most users.
There's a preview of their new version coming out. Have you started to look at that yet?
I personally have not, but we
Okay.
do have people that have. So.
Okay. Other questions? Yeah.
The Linux dude with the head nod, the Linux nod. That's what I'm going to call it the rest of the day.
Hi, I was wondering if you guys have been thinking about, or if anyone's approached you about non-game applications through Chrome native client? Like any possibility, like a video editor in your browser or something like that, to that effect?
Yeah, absolutely. We get a lot of people talk. So video games is sort of the critical point, right? You get high performance, you get high entertainment value, and you get it to the masses. There's nothing stopping non-gaming software from using native client. In fact, we highly encourage it. We've done a lot of tests internally about using the modern WebRTC standards that have just popped up, actually using WebRTC to capture audio and video through the user's webcam, passing it across the bridge to native client, doing processing there, and then potentially pushing it back. In the same methodology, you can actually do arbitrary blob loading through Chrome and native client, right? So you can actually ask the user to upload a given file, a video file, do all of your processing with your native code and native client, and then potentially push it right to YouTube with the YouTube APIs as well. Actually, to piggyback off that, there's a full repo that you can find on the GoNackle website called Knackle Ports. And Knackle Ports actually, it's a massive source code repo that actually lists ports of common open source software to the native client platform. For example, SDL has been fully ported over to native client, Ogre has been fully ported over to native client, and FFmpeg as video editing software has also been ported over too.
Can I ask one more question? I'm just wondering if
See,
you have
two
any
questions. You guys cheat.
Do you have any are there like a set of profiling tools for the platform?
So we don't provide profiling tools directly as of yet. That's something that our development team is really adamant about. But if you check out the GoNackle website, we actually have detailed instructions about how to use external tools for it, like vTune and some other popular processes.
Thank you.
Thank you. See, I'm waiting for someone to ask 3 questions in one question. That is the leader of the room there.
Did you solve the breakpoint problem?
Which breakpoint problem?
You stated that there was a problem with breakpoints with these other interpreted language, but then you never stated if you solved it with native client.
Yes, we have solved it. So we actually support 2 development paths with native client. One of them is actually as a Pepper plugin, so you can actually do all of your porting over to the Pepper API without actually having to go through our compiler. So you can actually just effectively generate a Pepper DLL and do all of your porting, all of your breakpoint setup, all of your pthread adoption and everything right there inside of Visual Studio's and IDE. And then once you're ready to compile as a native client module exactly, we do have an additional debugger there that will, through WinGDB setup, allow you to set breakpoints, breakpoint it right in the code. And here's the coolest part. With Chrome, you can actually set breakpoints inside the executing JavaScript using the developer tools, right? So you can actually set breakpoints inside of JavaScript and inside of C++ and actually kind of get this nice little lockstep as they communicate back and forth to each other. So it's a very powerful tool suite that we're trying to adopt. And by the way, the tool suite is there. Our team is very adamant about ensuring that it's high quality, and we've got a handful of people that's focused entirely on polishing that suite. So it'll keep getting better and better and better. Wait, sorry, I need a microphone. And he's asking about non-Windows developers. Stay tuned. That's all I can say. Stay tuned. Subscribe to me on Twitter. Stay tuned.
Any other questions? All right, well, great. Thank you so
Excellent.
much.
Thank you guys for your time.